Today we're going to talk about another type of angle inside a circle, and this one's called an inscribed angle. The location of the angle is different than the central angle, because if you notice, it's an angle whose vertex is on the circle. It is not in the center any longer. So here are three different examples of an inscribed angle. As you notice, the vertex of the angle is all located on the circle. So now we remember that central angles equal. We'll learn what an inscribed one is because it is not equal anymore to the arc it opens up to. So the intercepted arc is the arc which is inside, or what the angle is kind of eating, kind of like that Pac-Man I said. That's called the intercepted arc. We will also talk about an inscribed polygon, meaning a polygon whose vertices are inscribed or all on the circle. So this is an inscribed polygon. The circumscribed circle is actually this circle that I just drew that is around the inscribed polygon. So we'll talk about quadrilaterals, but you can have any shape inside of a circle. Let's talk about the inscribed angle and what we know the relationship is. So here's our inscribed angle. Here's arc AB. So we know that the measure of the angle is half of the arc. So the angle, I'm going to put a little half symbol, it's half of the arc it opens up to. So if you're trying to go to the outside of the circle and find the arc, it's times 2. All right, so remember that relationship. All right, so here is the little hourglass looking shape. We have shape ADB, that angle there, okay? And we just want you to realize that that angle, ADB, is the same as angle ACB, okay? Because the reason why they're the same is because they actually both open up to the same arc. Angle C here and angle D here open up to that same arc. So that's why they are going to be equal. So make sure you're tracing and finding what arcs the angles open up to. So let's put some numbers to this. One on the top left, it says find angle S. So I'm going to highlight that. Angle S is here. Well, we see that it opens up to the arc 60. Well, remember, this is going to be half. So if we divide 60 by 2, we get the angle to be 30. I'm going to go ahead and erase that part. Okay? Now we're trying to find the arc RQ. Well, if you notice, there's no angle that opens up to that arc. So let's take a look at some of the other information. Well, they gave us 37, so I'm going to just multiply by 2 to get the outside of that, which would be 74, right, to help us find our Q. And the reason I'm doing that is because if you pay attention, diameters are going to be really important because remember, what does the diameter do to a circle? Cuts it in half, so that arc that I just labeled is 180. So to find our Q, I'm going to do 180 minus 74. 180 minus 74 leaves us with the arc to be 106. Okay, so always look for the diameter. Let's look at the second one here. We're trying to find the measure of arc A, or angle AOC. Well, that angle opens up to this arc. Well, if you take a look, CBA opens up to that same arc. Well, this is inscribed, so to get to the outside, we're going to multiply by 2 to get to 120. Now, the angle AOC, where is it located? It's located in the center. So remember, central is equal. So the measure of AOC is actually equal to 120. Okay, always look for the location. Inscribed, central, two different. They're either equal or half. All right, last one down here, we're going to try to find the arc YZ. Well, that angle that opens up to it is 50. So 50 times 2 gives us 100 for the arc. Okay, I'll erase that work. Now we're trying to find the angle YWZ. Well, if you notice, it opens up to that arc. Well, we just found that arc to be 100. So divide by 2 and you get 50. This is actually that hourglass looking shape that we just looked at. So that's 50 degrees. So this open up to the same arc. All right, so let's talk about triangles, of course, inside of a circle. It says if AC is the diameter. Okay, so it's cutting the circle in half. What do you know about the triangle? Well, we know this is 180 Well, take a look at angle B. Angle B opens up to 180. Well, 180 divided by 2 gives me a 90-degree angle. So I have a right triangle inside of my circle if the diameter is located there. So let me erase this. So let's look at this problem. Well, we know this is a 90-degree angle. It tells us that ACB, this angle here, is 42, and we're trying to find this arc. So what I would think to do is, all right, I'm going to find this other angle A because A opens up to that. Well, using my triangle with 180, we go ahead and subtract from 180 the 90 and the 42, and we get this angle to be 48. So 48 times 2 to get to the outside of the circle gives us 96. Okay, so this is 96. All right, so now we're going to talk about an inscribed polygon and specifically talking about quadrilaterals. Okay, we know something about the relationship of the angles in a quadrilateral inside a circle. We know that the opposite angles are supplementary. If it's inscribed, meaning all the angles are on the circle. So that means angle E plus angle G equals 180. Angle D plus angle F equals 180. Opposite angles. Alright, so let's take a look at two problems. The first one just says find the values of x and y. So you're looking at this. 3y and 3y are opposite. 8x and 4x are opposite. So we're going to add them up and set it equal to 180. And then do your algebra work. So it should look something like this. 3y plus 3y equals 180. You do your algebra, you get y to equal 30. 8x plus 4x equals 180. Do your algebra, you get x to equal 15. Now this one's slightly different. It's asking for the arc DCB. Okay? So how we figure this one out is, all right, let's figure out what angle opens up to the arc. Hopefully you can see here are the endpoints. Well, that's the endpoint of that angle A up there. Well, we can actually find angle A. I'll put an X there because we know that 35 plus X should equal 180. They're opposite angles. So when you do that, you get angle A to be 145. Well, angle A is an inscribed angle. It would be something like this. If you had an angle here, 145, how do you find its arc? Well, we multiply by 2. So DCB is going to be 290. Okay? Don't forget about inscribed being on the circle and multiplying out. All right, this is slightly different. We call this CT because you have a chord and a tangent line. But if you notice, the location of the angle is still on the circle. So this is kind of like an inscribed. Therefore, we know that it's still half of the arc. Okay, so the angle is still half of the arc it opens up to. It just looks different because you have this tangent line now part of your one side of your angle. So let's look at two problems. So we're trying to find the angle that's associated with the arc 246. Well, divide by 2 because that angle is on the circle, and you get 123. So that's angle W. Now remember, this is going to be a straight line, so if they wanted, let's say that was Z, you would do 180 minus 123 because this tangent line is a line. So let's look at this last one. It says find the measure of angle BCQ. Well, that opens up to this arc. So let's take a look what we know about that arc. Well, they give us 25, so let's highlight that. Oh, it opens up to that same arc. And this is an inscribed angle, so if you multiply by 2, you get 50 for the arc BC. Well, now we have this arc that opens up to it, divide that by 2. So actually, BCQ is 25. All right, please remember the difference between central and inscribed. Pay attention to where the angles are located.